So go ahead and turn to your homework logarithms, and we're going to do number 1 together. So we will rewrite this in the exponential form. Log base y of 106 equals x. So first we will identify what b, x, and y are. So b, in this case, equals y. X equals 106. And y equals x. So using this rewritten formula right here, we have y to the x power equals 106. And that's our answer. That is the exponential form of this log equation. So on number 5, we're going to rewrite this in logarithmic form. So just like the other problem, we're going to identify what b, x, and y are. So b is going to be a. Our y equals 4/3, and our x is b. So when we plug these in, we have log base a of b equals 4/3. And that's our answer. That's our logarithmic form of the equation right here. So if we go down to number 10, we're going to evaluate this by hand. You could also put this in the calculator, but it's really quick to do it just by hand. So on number 10, we have log base 5 of 125. So let's first rewrite this in the exponential form, and it might look more familiar. So 5 is b, x is 125, and y is our unknown. We don't know what it is yet. So from there, we have 5 to some power equals 125. So if you remember from your exponential quiz and the notes, we know that 5 times 5 times 5 equals 125. There's 3 5s here, so it's going to be 5 to the 3rd power. So y equals 3. So basically log base 5 of 125 equals 3. And that's our answer. So for number 13, we're going to go ahead and put this one in the calculator. We're going to round to the nearest thousandth. That's 3 decimal places. So on number 13, we have log base 6 of 41. If you're not using a TI Inspire, then you'll probably have to use a change in base formula, log of x over log of b, because most calculators will only have a base of 10 or e. You can't put a specific one in like 6. So if we put that in a calculator with our change in base, we have log 41 over log 6. So if we put that in, which is, by the way, control, and then this button right here with the 10. Since this calculator lets you put in a base, we'll just put in 10 for right now. And then 41 over log base 10 of 6. So that's 2.073. We rounded 3 decimal places. And as you can see up here, if you put in log base 6 of 41, as it is in this calculator, you get the same answer. So we're going to go ahead and write that out. So x is approximately 2.073. Okay, let's move on to number 18. We're going to be graphing. So if you look at the parent function of ln of x, here's our graph. H equals 0, k equals 0. We have an asymptote at x equals 0, which is just our h value each time. And the domain is 0 to infinity, which, by the way, this 0 is also going to be corresponding to h value again. And then the range is all real numbers. So if we go over here and look at this, our h is going to be -6, k is 5. The asymptote is that x equals -6, because that's our h value in this case. Our domain is from -6 to infinity, and our range is all real numbers. So let's go ahead and first graph the asymptote. So we're going to write that out right here. Here's our asymptote line, and then we could just draw our graph from there. And that's it. Okay, and then number 21, we're going to be solving by basing both sides. So on number 21 of the same section, we have log base 19 of 20 equals log base 19 of 5x minus 10. So when we write that out, to get rid of the logs, we have to base both sides by 19 to get rid of them. So we just put a big 19 in front of both of these. So that cancels these two things out. So now you're just left with 20 equals 5x plus, minus 10. You'll just use algebra 1 from here. Add 10 to both sides. 10 minus 10 is 0. 20 plus 10 is 30. So now we have 30 equals 5x. Divide both sides by 5. So now x equals 6. Now go ahead and turn to your homework solving logs day 2. This is when we're going to use a calculator after doing this. So first, if you recall from your foldable notes, first we need to condense this down. So recall that log x plus log y is the same thing as log of x times y. So that means that ln x plus ln 10 is the same thing as ln 10 times x. And then that equals 2. So to get rid of the ln, the base is e. Natural log's base is e. So we're going to do that to both sides. We have 10x equals e to the second power. Divide both sides by 10, and you get your approximation. So you have e to 2 divided by 10, and that equals 0.7389.